Now moving on with the part B of first internal test, that is similarity and dissimilarity in feedback. We will start with the fifth question, that is briefly outline how to compute dissimilarity between students' feedback profile described by. First is nominal attributes, that is department, elective, chosen. B is asymmetric binary attributes, that is attending workshops, or that is yes or no. C is numeric attributes, example CGPA, attendance percentage. And the D is term frequency vectors, that is keywords in open text feedback. So let's see its solution. So the first is nominal attributes. So the normal attributes have no inherent order. So its dissimilarity measures are simple no match rate or nominal distance, that is calculated by d of ij point, that is calculated by p minus m by p, where p is the total number of nominal attributes and m is the number of matches, where the value for students I equals the value for student C. For example, if I and J choose the same department but different lecture, then P is equals to 2 and M is equals to 1. So the distance will be 2 minus 1 by 2, that is 0.5. Then let's see its B part, that is asymmetric binary attributes. So these two have two states, that is 0 or 1 or yes or no, where 1 is a significant state and the absent of trait is 0 match, that is usually ignored. So the dissimilarity measure, that is Jacob coefficient. So it is d of ij is equals to 1 minus a upon a plus b plus c, that is b plus c upon a plus b plus c, where a is the number of attributes where both I and j are 1 match. B is the number of attributes where I is 1 and j is 0. C is the number of attributes where I is 0 and j is 1. And the D is number of attributes where both I and J are 0, that is 0 match, that is ignored. So this is how it is calculated. Then moving on to the C, that is numeric attributes. So the attributes like CGP or attendance are quantitative. So the dissimilarity measures is calculated by monoxide distance. So monoxide distance, the formula is mm, d of ij is equals to under root of summation uh, I of k and x of I or x of j to the power h. Now the d is term frequency vectors. These are often high dimensional sparse vectors representing keywords in open text feedback. So the dissimilarity measures, that is calculated by cosine dissimilarity, that is 1 minus cosine similarity. So the cosine is preferred because the magnitude length of the vector can be misleading. So it is calculated by v of I into v of j upon uh, the v of I into v of j, uh, in which the value will always be positive. So the dissimilarity is equals to 1 minus cosine similarity. Now this was all about fifth question. Moving on to the sixth question, that is student faculty interaction profiles. So suppose two student faculty interaction profiles are represented as triple S1 and S2, where attributes represent hours spent in mentoring, project reviews attended, assignment submitted, infrastructure usage. Count that, and we need to compute the Euclidean distance, Manhattan distance, Monoxy distance with h is equals to 3, and supremum distance. So to calculate the Euclid's distance, that is h equals to 2, we will take the distance. So the under root of uh, from value we will take from S1, that is 22, and its first value, that is 20. So 22 minus 20 square plus 1 minus 0 square plus 42 minus 36 from S2 square, then 10 from S1 and 8 from S2 square. So the D becomes approximately equal to 6.708. Now to calculate the Manhattan distance in which the h is equals to 1. So the distance will be the true value of 22 minus 20 plus 1 minus 0 plus 42 minus 36 plus 10 minus 8, which will give us 11. Now moving on to the Minoxidil distance, which we need to calculate using h is equals to 3. So we will apply the formula and we will get it approximately equal to 6.153. Then to calculate the supremum distance, so in this we take the maximum of x and y. So we get the maximum is equals to 6. Now moving on to the seventh question, that is median score heuristics. So the question given is the median score is often a key heuristic indicator of faculty or infrastructure performance when dealing with massive student feedback data sets. So purpose methods for median approximation analyze their complexity and suggest heuristical to balance accuracy versus efficiency. So let's see his answer. So the answer is for massive feedback data sets, computing the exact median requires sorting the entire data set, which is highly inefficient with a time complexity of O, big O, of n log n, where n is the number of records. So methods for median approximation is random sampling, approximation quantile algorithm, and quantile histogram. So its description is the description of random sampling is draw a relative small random sample of size n, which is less than whole n, which is the total number of sample. So the median of its sample is used as an approximation for the population median, and its complexity is big O of n log n, and the accuracy or efficiency trade-off is that it is highly efficient. That is, accuracy depends on the same size and distribution of data. Now we'll see approximation quantile algorithms, that is p-square algorithm. So these are single pass algorithm designed to estimate quantiles like the median Q2 with high accuracy without storing all data or sorting. Its complexity is big O of n, that is single pass. Then it is excellent balance, very high efficient and maintains high accuracy. Now the quantile histogram. So it is group the data into bins. The median is estimated by interpolating within the bin that contains the n by 2 count. So its complexity is big of n, and it is efficient. So less accurate than p square, but simple to implement and very fast once the histogram is built. Now, this is heuristics to balance accuracy versus efficiency. So the best heuristics is to use an approximate quantile algorithm among the three. So in this, we select the p-square. That is, use the p-square algorithm to calculate the approximate median. Complexity analysis, it runs in big O of n time and requires only a small constant amount of memory, that is big O of one space, making it extremely efficient for massive and streaming data. Third is accuracy or efficiency. So it provides a great balance. The complexity is only slightly higher than just reading the data. That is big of n versus big of n log n for exact median, while its accuracy is high and can be bounded mathematically. Now moving on to the next question, that is question number 8. So the question number 8 is consider student faculty similarity analysis. So a sample data set of two attributes, that is faculty responsiveness and infrastructure support, is the student A1, A2 and student S1, S2, S3 and S4 and S5. and its attributes are a1 and a2, which are given as below. So in this, we need to calculate given a new feedback query, that is q is equals to 1.4, 1.6. So in this, we need to calculate rank existing students' feedback profile by similarity using Euclidean and Manhattan supreme and cosine similarity. Also normalize each student's vector to unit length and compute using Euclidean distance. Then the query Q is equals to 1.4 and 1.6. Student SA is equals to A1 and A2. In this, we will see the first ranking by similarity, that is using dissimilarity. So rank students from most similar to least similar. So in this, we will draw a chart in which we will uh, apply all the formula Euclidean, Manhattan, supremum, and cosine dissimilarity. So we will get the following values. Uh, now, now we will see the calculation details for S1. So we know the formula and we will apply it and we will get the value of um, like this, like 0.00037. Now the final ranking, which is most similar to least similar. So we will measure Euclidean, Manhattan, supremum, cosine. So we will get that Euclidean is rank 1 and Manhattan as 0.2, and we will put the uh, value. So we will rank in this following way. So for supremum, S3 and S4, uh, S3 and S4 share rank 2 and S5 and S2 share rank 4. Now let's see this normalization and recomputation of Euclidean distance, that is normalized vector, that is SI. So to calculate the normalized to v square v dash, that is such that v dash is equals to 1. So v upon v dash. So in this we will get the normalized vector as approximately equal to 1.8028. Now this was all about this. Now we will calculate the we will recompute the Euclidean distance. So applying the formula, we get the values of S1, S2, S3, and S4 and S5. So we will put all these values in cosine similarity. That is 2 into 1 under root of 2 into 1 minus cosine similarity. So in this, we will get the cosine similarity too. So it was all about part B. We will solve the next part in the next video. Thank you.